This video is about Poisson distribution. Question for you. If a call center receives 3 calls per minute on average, what's the probability of receiving exactly 5 calls in a minute? This question can be solved by the Poisson distribution. The Poisson distribution is a discrete probability distribution that expresses the probability of a given number of events occurring in a fixed interval of time or space under the following conditions. The events occur independently of each other. The average rate events per interval is constant. 2 events cannot occur at exactly the same instant because the events are discrete. Here is the formula for Poisson distribution. In IB Math AIHL, we won't use this formula. We will calculate Poisson distribution by calculator. This M is the mean number of incidents within a certain period. In other words, this M is the average rate. Here is the information given in IB AIHL formula booklet. X follows Poisson distribution with the average rate M. The mean equals expected value equals this average rate. Variance in Poisson distribution equals M. In other words, standard deviation equals square root M in Poisson distribution. Question 1a. It's assumed that the number of calls received can be modeled by a Poisson distribution. If a call center receives 3 calls per minute on average, find the probability of receiving exactly 5 calls in a minute. From the given information, we know M equals 3. X follows Poisson distribution with 3. We are looking for probability of X equals 5. Let's go to calculator. Go to this scratch pad. Menu. Go to 6. Go to 5. Upper arrow button. We got to use Poisson PDF because we are looking for exact value. J. Lambda is average rate 3, X value 5. Enter. Answer is 0.101 at the 3 figures. Let's go to 2. Receiving no more than 5 calls in a minute. M equals 3. X follows Poisson distribution with the mean 3. We are looking for probability of x less than or equal to 5. We got to use Poisson CDF. Menu, go to 6 statistics, go to 5 distribution. Upper arrow button, go to K. Lambda is 3. Lower bound is 0. Upper bound is 5. Enter, enter. Answer is 0.916. Let's go to question 3. Receiving less than 5 calls in a minute. We are looking for probability of x less than 5. Make sure you change this into less than or equal to 4. Then you put this into calculator. I can go up, down, change this 5 into 4, enter, 0.815. Let's go to question 4. Receiving at least 5 calls in a minute. Probability of x greater than or equal to 5. So lower bound is 5. Upper bound, put in big number. Go to menu. 6, 5. Upper arrow, go to K, Poisson CDF. Lambda is 3. Lower bound is 5. Upper bound, put in really big number. Answer is 0.185. Let's go to question 5. Receiving more than 5 calls in a minute. Average rate equals 3. X follows Poisson distribution with 3. We are looking for probability of x greater than 5. You need to change this into greater than or equal to. Probability of x greater than or equal to 6. For probability of x less than a, in discrete distribution equals probability of x less than or equal to a minus 1. So less than less. Remember, this is in discrete distribution. For probability of x greater than a equals probability of x greater than or equal to a plus 1. Greater than greater, you need to add 1. This rule applies to all the discrete distribution, including binomial distribution and a Poisson distribution. Let's go to calculator. I can pull this down. Change lower bound into 6, then enter, 0.0839. Let's go to question 6. Receiving more than 2 but less than 7 calls in a minute. We are looking for probability of x greater than 2, less than 7, equals probability of x greater than or equal to 3, less than or equal to 6. Let's go to calculator. K. Poisson CDF. Lambda equals 3. Lower bound is 3. Upper bound is 6. Enter, enter. Answer is 0.543. Question 1b. It's assumed that the number of calls received can be modeled by a Poisson distribution. If a call center receives 3 calls within 2 minutes, on average, find the probability of receiving 8 calls in 4 minutes. You could say the interval of time is changed within 2 minutes, but we are looking for receiving 8 calls in 4 minutes. So first step, we need to figure out this average rate in 4 minutes. 3 divided by 2 times 4 equals 6. So X follows Poisson distribution with 6. We are looking for probability of X equals 8 equals. Let's go to menu 6, 5, upper arrow, go to J, Poisson PDF. Lambda equals 6 instead of 3. X value is 8. Enter, enter. Answer is 0.103. Let's go to question 6. Still, we need to figure out M equals 3 over 2 times 6 equals 9. We will use different variable because M is changed. Y follows Poisson distribution with 9. We are looking for probability of more than 10 calls. So Y greater than 10 equals probability of Y greater than or equal to 11. Let's go to Poisson CDF. Lambda is 9. Lower bound is 11. Upper bound, we put in big number, 3 or 4 nines. Let's do 4 nines. Enter, enter. Answer is 0.294. Let's go to question 7. Receiving no calls in 3 minutes. We need to figure out the average rate M first. 3 over 2 times 3. We got 9 over 2 or 4.5. Z follows Poisson distribution with 4.5. We are looking for probability of Z equals 0. Let's go to Poisson PDF. Lambda equals 4.5. X value equals 0. Enter. We got 0.0111. Let's go to question 8. Receiving at least 10 calls in 7 minutes. Average rate M equals 3 over 2 times 7. we got 10.5. V follows Poisson distribution with 10.5. We are looking for probability of V greater than or equal to 10. Let's go to calculator. 10 is the lower bound. Poisson CDF. Lambda is 10.5. Lower bound is 10. Upper bound, put in big number. Enter, enter. Answer is 0.603. Answer is 0.603. Let's go to question 2a. George goes fishing. From experience, he knows that the mean number of fish he catches per hour is 1.1. It's assumed that the number of fish he catches can be modeled by a Poisson distribution. On a day in which George spends 8 hours fishing, find the probability that he will catch more than 9 fish. M equals 1.1 times 8 equals 8.8. X follows Poisson distribution with 8.8. We are looking for probability of x greater than 9, which means the probability of x greater than or equal to 10. Go to Poisson CDF. Lambda is 8.8. Lower bound is 10. Upper bound, put in big value. Enter, enter. Answer is 0.386. Let's go to question 2b. When Jeff plays basketball, the number of shots he takes during any 6 minutes of play can be modeled by a Poisson distribution with a mean 2.5. Find the probability that Jeff takes less than 7 shots during any 12 minutes of play. M equals 2.5 over 6 times 12 equals 5. X follows Poisson distribution with a mean 5. We are looking for probability of x less than 7 equals probability of x less than or equal to 6. Let's go to Poisson CDF. Lambda is 5. Lower bound is 0. Upper bound is 6. Enter, enter. Answer is 0.762.